Hi everyone, my name is Alex,
I'm Anthony.
I'm Chris.
And I'm Matthew.
and we're the team behind MeetSafe, a web application that's designed for a dynamic meeting assignment that minimizes contact during travel. But what does that mean? Let's find out a little bit more. Here at MeetSafe, our goal is to change the world one meeting at a time. As more and more organizations adapt to the current climate, we wanted to build a tool that facilitates a safe and responsible return back into in-person meetings, albeit smaller ones. Our MeetSafe tool is a simple and clear web application that allows institutions and organizations to upload some of their information about person, room, and meeting information, and our tool will do the rest. We'll optimize your travel contact based on the routes, and we'll analyze the results for you. But for more on our input data, here's Anthony.
Thank you, Alex. In our data inputs, we have 4 data tables. These tables are meant for universities and institutions to input their data to get an accurate result to be COVID compliant. Our first table is a person table, which has all the people, what meetings they're going to, and what room they're starting in. Our second table is a location table. That's just the locations of all of the possible locations that someone can be in the company. The third table is our network table, which has 2 nodes that connect to each other. This is meant to find the shortest path in between 2 possible locations and track how many interactions there are between people throughout their time traveling from one location to the next. And last is our meeting table, which has the meeting names and the meeting start times. Next, I'll pass it to Matthew, who will talk about optimization and results.
Thank you, Anthony. So as Alex uploads one of our data sets, I'm going to talk to you about what our algorithms do. In our computational solution, we look to minimize the total number of interactions which occur as people are traveling between meetings. To do this, we formulate and solve a convex optimization problem, which assigns meetings to rooms based on the information about who is attending a meeting, what route they'll use to travel to that meeting based on the room that they'll start in, and the number of people that they will encounter over that route. This optimization problem assigns meetings to rooms in a way which minimizes the total number of interactions which occur. So you can see in our results here that we have 5 meetings occurring on campus at our home residential college, Hansen College. And in the middle column, you can see the room to which these meetings were assigned. So the first meeting at 4 o'clock is a comp class, and it's assigned to Hansen 202. And then our next meeting, a CAM class, is assigned to the commons. So we'd now like to run our program again with a slightly larger data set, which represents a larger part of Rice's campus. So as we run this, our convex optimization algorithm is going to find the optimal locations to place each of our classes. So as our results come up, you can see that we have a set of 20 classes that we've assigned to different locations. So you can see in the middle, we see the rooms in which each class was assigned. On the left, you can see the class. And then we also have a column identifying the meeting time. On the right side, we have some information which tells you a little bit about the number of people and the number of interactions are occurring. So we have the number of attendees for each class. And on the right, we have a score, which is the average number of interactions that each person attending that meeting will have on their travel to the location. So we can sort by this score to identify meetings with high scores, which are high-risk meetings causing a lot of interactions to occur. So these are prime candidates to move that meeting online and reduce the number of interactions which are occurring. Additionally, we can search the table by class or by room to identify places where a lot of meetings are being held over the day or places where fewer meetings are being held. Now I'd like to have Chris talk about future steps for our project.
So if we had more time on this project, first things that we would do is that we would make it so that our MeetSafe could handle continuous meeting times. So right now we can only handle meetings that start and end on the hour. So we would like to have meetings that could start at 3:15 or end at 4:30. Next, we'd like to adjust the schedule based on the results that we find. We'd like to add detours to certain bottlenecks and maybe even recommend that certain meetings go online. Finally, we'd like to visualize the network and the number of people traveling to and from certain meetings in order to help people understand which places are at high risk. We're excited to bring a product that will facilitate the safe and responsible return to in-person meetings to institutions around the world, Thank you for listening to our presentation.